this is the last of my parabola conic section videos. So this one is dealing, it says find the equation of the line tangent to a parabola at a point. So I want to talk through a few basic ideas first. You remember the definition is that the distance from any point on the parabola is the same to the focus as it is to the directrix. Okay, so pretend that if this really were a parabola, this right here would be congruent to that right there. And so what we're going to do is we want to come up with the equation of this tangent line. And what happens is that we can make a rhombus so this distance here, we can come down this much here. Is that about the same? And then we can come down when this makes a rhombus, and this one is parallel to this one right here. So when all of these, this piece and this piece, when all of these are congruent, this line that goes through the diagonal of the rhombus, that goes through this point, pretend I can draw. Okay, there's a line. This line right here ends up being tangent to the parabola. So what we're going to do, so in this first problem, so we figure out how long these distances are, and then we come down this way, and then we write the equation of that line. So the goal is to find a rhombus and then go from there. So here was the problem they gave us, and they said that y squared is equal to 8x. So x is equal to 1/8 times y squared. So this one is going to open to the right, and the vertex is the origin. Okay, so when I graph this, I'm going to do the best I can to be somewhat to scale. I'm here at the origin, and then my p-value is 2. So I'm going to come 2 for the focus, and then 2 this way for the directrix. And now they're telling us to find the point 8, 8. My scale, 2, 3, 4, 5, 6, 7, 8. Okay, something like that. Well, when we do know that this one is going to be that my LR 1, 2, 3, 4 is going to be about here. 1, 2, 3, 4, and about here. My scale is kind of terrible. This is going to be really big. Okay, so there's roughly my parabola, and they wanted the point 8, 8 right here. Well, so here's what we know. We know we can find, to find the slope that's tangent here, we want to find the equation of the line, we need to find that rhombus that we were talking about. So the rhombus goes from the focus to that point, from that point to the directrix. That's going to be something like here. And then we can make, those would be two sides of that rhombus. So then the other side, notice that this is the point, 8, 8. This is the equation, x equals -2. So that has a length right here of 10. And we can go on this one, where this is the point 2, 0. So I went over 6 and up 8. 6, 8, 10 gives me, this is also a length of 10. So there's one way for us to see that it has a length of 10. My picture may not be perfect, but let's go with it. And so now the other side of the rhombus is going to be 10 units behind this. So when I come back, I kind of fall off the page, but let's pretend it's right here. This should be a rhombus where all the side lengths are 10. If that's the case, then this becomes the point -8, 0. And so my tangent line is going to be the line that goes through this point here and this point here. So when I know those two, I have 8, 8 and -8, 0. So it's a change in y, 8 minus 0 over 8 minus -8. This is 8 over 16. Okay, this has a slope of 1/2. So now y is, sorry, I was going to start with point slope. Y minus y1 equals m times x minus x1. And so pick one of these points. Okay, y minus the y value is equal to 1/2 times, does that make sense? Is that a positive slope? It is. X minus 8. So y minus 8 is equal to 1/2 x minus 4. Add 8. I have y is equal to 1/2 x plus 4. And that's the equation of the line that's tangent to the parabola. You definitely want to practice this a little bit to kind of get it in your head. But it deals with, look for the rhombus. That's what you want to do. Good luck.